All right, number 8 says that we have this point negative 13, 12 on the graph of y equals f of x. Okay, so this is what that means. We have this point negative 13, 12. So this is the x coordinate, this is the y. So if I were putting this in function notation, that means f of negative 13, when x is negative 13, the y value that we get is 12. Okay, that's how you interpret that. Now we want to find the point y equals g of x. Okay, and it says g of x is equal to 1/3 of f of x. Okay, so g of x equals 1/3 f of x. Okay, so what is f of x? What is f of x? F of x is equal to y. Y equals f of x. That's what we're told. Or you need to understand that y and f of x are the same thing. So if I do 1/3 of f of x, what I'm really doing is 1/3 of the y value. Okay, the y value is 12. So I'm doing 1/3 of 12, which gives me 4. So the y value is changing, but the x value is still staying the same. So the new ordered pair that we get is negative 13, and then the y value is now 4. So this is how you interpret that. It's just a bunch of symbols getting you to understand how to find a new ordered pair from using the rules of transformations. So the corresponding point, the new ordered pair, is going to be negative 13, 4. All right, so number 9 is something similar. So again, using the rules of transformations, we want to figure out the new corresponding point. So we have the point negative 13, 8. Okay, and then we're told that y equals f of x. So you can put all that together. And we want to find the corresponding point y equals g of x if g of x equals negative f of x. So g of x equals, I guess, actually f of negative x in parentheses. So this just changes the x coordinate. It flips across the y-axis. So if you had a graph, okay, and I had some x value over here, let's say 2, and I make it negative, now I'm at negative 2. So it's flipping across the y-axis, but all it's doing is changing the sign of the x. So x was positive, now x is negative. So if I take this ordered pair, x and y, x was negative, it now changes to positive, and that's unaffected.